Question number 3 wants us to define the domain of this function, and it gives us some choices here. So just for the interest of time, what I would probably do is I'd go ahead and try to graph this in my calculator. So if you go to the graph screen and type it in as it says, okay, so domain is a way to describe the x values that it's hitting. So looks like it's hitting all of these x values, and then it hits all of these x values, and it hits all of these x values. I'm a little suspicious here. Okay, so even though it looks like it's hitting all of these x values, it's actually missing where x equals 0. So I can certainly see I need to throw out -3, and I need to throw out +3. Notice there's no x values there. But it's not so obvious just looking at the graph that x equals 0 is not possible. So a good strategy here, if you hit second graph, you can look at the table, and depending on what your table settings are, you can see all these different x values, and it's hitting all these values, but something's happening at -3, 0, okay, well that froze up, but also wasn't hitting at +3. So let's think about this algebraically and try to figure out how were we supposed to know that. Okay, so the equation said, I've got to copy it over here. Y equals x minus 9x to the -1 to the -1. Okay, so more of an algebraic approach, which will definitely help us catch that 0 is not a possibility, is we just think about what numbers can we not plug in here. There's two ways that domain gets restricted. Domain is only interested in real numbers, so we can't take the square root of anything negative, but as you can see we have no square roots here. And you can also not divide by 0. Dividing by 0 is undefined. So when you try to divide by 0, those numbers get taken out of the domain. So to move this forward, because it doesn't look like there's any denominator here, but to move this forward, we can use a property of exponents that says if you have a negative exponent, let me think of all this as a fraction. If you have a negative exponent, you can change it to a positive exponent if you take the reciprocal of what is inside. Like that. Okay, and then another exponent rule says if you have a negative exponent, you can move it to the other side of a fraction bar and make it a positive exponent. So let me put this over 1 so we can see this x to the -1 can move down here and become x to the +1. Alright, now we can see some denominators. So again, one of the ways that domain gets restricted is for x values that try to make you divide by 0. So right here, we can see x cannot be 0. If you try to plug in 0 into that, you're trying to divide by 0, which of course is not allowed in math. But we also have this big fraction as well. We have to make sure that it doesn't equal 0. So to figure out where that's not possible, let's figure out where it does equal 0, and then we'll make sure we throw out those numbers as well. Alright, so I don't like this, and then it has some fractions in here, so I would multiply everything by x so that I can rewrite it without fractions. 0 times x is still going to be 0. And this is a quadratic that can be solved with factoring. This is the difference of two squares. So it factors as an x plus 3 and an x minus 3. And so it looks like this big denominator equals 0 at 3 and negative 3. So we have to throw those out as well. So x can't be 3, x can't be negative 3. Okay, so graphically, we saw these two pretty quick. We saw those are called asymptotes. Those x values were messing up on the graph. This was not so obvious. I did see it in the table, but it would have been pretty easy to overlook. So now that I know which numbers x cannot be, let's look at how we would write that in interval notation like they did. Okay. So again, x can't be 0, x can't be negative 3, x can't be positive 3. That's what I found from the algebra. So if we think about a number line, we can plug in anything, but we need to make sure we don't include 0, we don't include negative 3, and we don't include positive 3. That means I need to include all of these over here. So that would be negative infinity to negative 3. Don't include the negative 3. It's an open circle. And all of these numbers, negative 3 to 0. And all of these numbers. And all of these. 3 up. So that is the correct answer, and that was choice B.